Happy Monday. It's a new week, a new you, and more solving quadratic equations. So today we are going to apply and extend what you know about solving a quadratic equation. So we'll solve them in some methods that you know, one method that you've known all along. This was the first of the 6 methods we had to solving quadratics, and one that you learned just recently, solving the quadratic formula. So here's the thing with solving quadratic equations is that you can really use any of those 6 strategies that we shared with you on any quadratic equation. So you just got to pick the one that works best for you. If zero product property works, you might want to do that. If it's really easy to use quadratic formula, you might want to do that. If you're allowed to use a graphing calculator, you might as well graph that and figure out where the x-intercepts are, and then you got your solutions for x. But they're telling us to do this here in zero product property first because it wants us to practice that. So let's get started. So zero product property, my A isn't 1 here, so I'm not going to have a shortcut that I'm going to want to use. So I'm going to want to do this the long way. There's really not a good way to do this in your head. I'm not going to be showing you some magic way that's going to allow you to solve this incredibly quickly because, hey, let's time this. This is only going to take like 90 seconds to do this. This is not very long at all. In class, it's not very much of class. So 6 times negative 10 is negative 60. Our B values are 11. Now we're going to have to figure out what adds to 11 and multiplies to negative 60. I'll have one negative value because the product is going to be negative and the sum is going to be positive. So the larger of the two is going to be positive and the smaller of the two is going to be negative in terms of the factors of this. So, I think I got it. Eureka. It's going to be 15 for my positive and negative 4 for that negative value. So 15 minus 4 is 11. Multiply them together, you get negative 60. 15x here, negative 4x here, and you guys know how to factor. You're hopefully mostly just checking your answer at this point for this one. So there I have my 2 roots to this polynomial, or the solutions to this quadratic equation, the values of x that are going to make this side equal to 0, or this side equal to 0, so that it's actually a true statement. So x equals 2/3, or x equals negative 5/2. Hopefully you got those ones here. Reminder, zero product property. Either of these factors could represent 0. So 3x minus 2 could be 0. If that's made a 0, that's going to make your product 0. If this is made a 0, that's going to make your product 0. So that's why we have 2 solutions. So we'll have one solution that we can determine from this factor, whatever makes that 0, and whatever makes this factor 0. And we would get a 0 product, and we would know that when it's 2/3, we're A-okay. We have a solution here. Solve it using quadratic formula. Okay, so this one, I'm going to sing the song. Yes. So it's a new week, a new you, but same old Mr. Fortin. I'm singing the song. The quadratic formula is, and I sing a longer version of this. This is a better, more amazing version here. The quadratic formula is when a quadratic's written in the form ax squared plus bx plus c equals 0, then x equals negative b plus or minus the square root of b squared minus 4ac. All over 2a. I sing that every single time, actually, because as you've noticed in the last video, if I don't sing it, then I make mistakes, okay? So I recommend sing it to yourself, right? Nobody's going to hear you. You're at home. None of your classmates are going to hear you and judge you, right? Not like they judge you really anyways. So, just sing it and get it done. We get the quadratic formula. And then it becomes easy. You did the fun part first, and then you do the easy part second, right? Math is all about doing fun things and then doing easy things afterwards, right? Okay, cool. Maybe I'll write down my A, B's, and C's here. You gotta know your A, B's, and C's. A is going to equal 6. B is going to equal positive 11. And then our only negative one is negative 10 here. That's our C. So we're going to have negative B, which is going to be negative 11 plus or minus the square root of b squared, so I get 11 squared minus 4. A is 6, C is negative 10. So notice here when I just wrote down my A, B's, and C's, it's just really quickly just to pop into this equation. And again, we'll prove where this equation comes from in chapter 10. I kind of talked about it on the last video, kind of went through some steps that you're allowed to do to rewriting this as this to prove that this is an equivalent way we can write that equation, but we'll prove it together when we get to chapter 10. All right, all over 2a, so all over 2 times 6. So x is going to equal negative 11 plus or minus, and the square of 11. So here's where you're in high school math now, guys. You're in high school math. Memorize the perfect squares 1 through 15, meaning if you square 14, you should know the answer right off the top of your heads. And you're probably not there yet, but you need some practice, and you should get there because you're going to be squaring stuff all the time. So 11 squared, I haven't memorized. Do you? It's 121, okay? So that's one to add to your list. Just go just put 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, and go all the way up to 15, and just practice it. Practice it like you used to practice multiplication tables, and then you'll be able to go through problems like this a lot faster and feel a lot better about them. Okay, minus 4 times 6 is negative 24. So a reminder here, you're not multiplying, you're not distributing 4 to the negative 10 or the 6. You're just, right, you're multiplying in the order that you have here. So negative 4 times 6 is negative 24. And then you have that negative 10 factor still here being as part of this whole statement. So you still need to multiply together. So you got negative 24 times negative 10, and that's adding 240. All over 2a, which is 12. And x equals negative 11 plus or minus root 121 plus 240 is 361. And I know that's a perfect square. Let's use my calculator to verify. 361, let's get the principal square root of that. Oops. 19. So this is plus or minus. We take the positive square root and the negative square root. Because remember, roots, we have 2 answers. We're going to get 2 answers here. This, if this were a parabola, it would cross the x-axis twice. But it's just an equation. We don't care about the parabola on this one. So negative 11 plus or minus 19. Because root 361 is positive or negative 19. And over 12. Okay, break up to 2 equations. I'm going to do one up here. X equals negative 1 plus 19 over 2. And x equals negative 1 minus 19 over 2. So we're going to get 2 solutions to this one. Bring them further down. I'll do this top one first. Negative 1 plus 19 is 18 over 2. I did something wrong. Oh, this should be 12. Negative 1 plus 19 is 18, and 18 over 12, if we divide the top by 6 and divide the bottom by 6, we would get 3 over 2 would be how that simplifies. And it looks like we're going to get the right answer because I got mistakes. I needed a negative 11 here. So this is negative 11 plus 19, and that's going to equal 8. And then 8 divided by 12, that's going to equal, if I divide 8 by 4 and 12 by 4, I would get 2 over 3. So 2 over 3 for my first solution. Second solution, negative 11 minus 19 equals negative 30. So I have negative 30 over 12. And that's going to equal negative 30 divided by 12. So I'm going to have to divide the top and the bottom by their greatest common factor. 6 goes into 12 twice. 6 goes into negative 30 negative 5 times, right? Negative 5 times 6 is 30. So I get negative 5 over 2. And my 2 solutions are the same, okay, are the same. So I didn't mean to make mistakes on this one when I started doing it. I didn't make the mistakes to do it on this one, but I'm actually kind of glad I made mistakes because this should illustrate a point to you. And that is you're going to have choices, okay? You're going to have choices of whether to use the zero product property to solve quadratics or the quadratic formula. And maybe you encountered this here too. Which one of these two did you make mistakes on? Which one of these did I make mistakes on? Was it the zero product property or was it the quadratic formula? Well, for me, at least, it was the quadratic formula. So look at this thing, right? This thing, even we can use it in any standard form equation that's equal to 0. We can use the quadratic formula and find our roots, find the answer. But there's a lot going on in this formula. It's likely you're going to make a mistake. So for me, I thought I wrote -1 over here, and I wrote -1 up there, not -11. And also, and I made another mistake at some point too that I had to fix. So my recommendation, whenever try to factor something first. If you can factor it, just use the zero product property. That's the thing that was introduced to you first, because I think you make fewer mistakes. Overall, in the students that I see, they make fewer mistakes doing zero product property. If something is factorable, the problem is it's not always factorable. So I'd say try factoring it, solve it. If it doesn't work out, then try the quadratic formula, because you're probably less likely to make mistakes. All right, check it out here. C, did the solutions for part A and B match? If not, why not? Yes, they match. We did not end up making any more mistakes. Yes, they matched. Right, both zero product property and quadratic formula, if used correctly, lead to the same solutions. All right, let's do the next problem. So this is just reminding you here that these is the criteria in order to be able to use the quadratic formula. It's got to be written in the form ax squared plus bx plus c equals 0. Oh, I never say this. If a doesn't equal 0, right? If a equals 0, then it's not actually quadratic. So that's kind of silly that they put that in there, right? If a is 0, it would cancel out the x squared term, and you need that x squared term for it to be a quadratic expression. So let's go ahead and do one of these, and then I'll have you do the rest. There's no reason for me to go through all these because I think I understand this here. So to use a quadratic formula, I usually go through, I'd say my A's, B's, and C's. Got to know your A's, B's, and C's. My A here is 4. My C here is -121. Uh-oh. What's my B? Well, if this were written in standard form, as a standard form trinomial, it would be 4x squared, and then plus, how many b's are there? How many x's terms are there? Well, there's 0. It would be 0x minus 121. I'm guessing when these problems have come up in class so far, similar, was it missing terms? You guys know what to do, and I bet you were fine on this one. So I'm just going to go ahead and solve it real quick so we have an example, and then you're going to do the rest. We'll play some music in the background, set the mood a little bit. You can pause it and then watch the answers in just a couple minutes. Negative b, so -0 plus or minus, well, this is pretty easy. 0 squared minus 4a, and c is -121. I know where this is going, all over 2a, so 2 times by 8. And this -0 is just 0, plus or minus we still need, and we're going to have 0 squared, so I'm still going to have the root, 0 squared, 0, and then we're going to have -4 times by 4 is -16, and -16 times by -121 is 1936. And then that's all over 2a, which is going to be 16, because 2 times 8 is 16. And then now I'm going to take my square root. Second button, if you have this calculator, square root's right above the squaring button, so it's the green, and if it's green, that means you need to hit the second button. The second button will select what's immediately above the button of your calculator, so that's square root symbol there. So root, and another trick here is I'm going to hit second answer, so there's this answer button down at the bottom. This is a good tool to use to make sure that you can grab whatever's already in your calculator as your last answer. And I'm putting this in here, right? So this is the square root of 1936. If I hit second and then answer here, right, it will put that answer in, and then I can take the square root of it. So it's 44. So this equals plus or minus 44 all over 16. Oh, wait a second. Divided by 16. Well, 16 doesn't go into 44, but it's a pretty clean number. It's a rational, not an irrational, but it's a rational number. So it is plus or minus 2.75 is our answer right there, right? Two solutions written kind of as one term right there. Hey, you might have noticed there was actually a faster way to do this. Like, why did we just do this using the quadratic formula? What is this here, guys? For those of you who watched the lesson video, factoring shortcuts over the extended kind of spring break that we have, the optional assignment I did, you should be able to tell me what this is. What is this here? Well, it's a binomial that we were able to factor, and it's a special binomial. That's right. This is written in the form of that, right? We have a perfect square here, and we're subtracting another perfect square from it. This is actually a difference of squares. There's a much faster way to do this, right? If we weren't required to use the quadratic formula, I would have just factored and solved this using zero product property, because remember that if you have a difference of squares, your factors are just going to be a difference of each other, a difference of the square roots, and then a sum of the square roots. That's their shortcuts of factoring, stuff like that. So this would have immediately factored, if we were just to immediately factor this one, we would have gotten 2x minus 11 times by 2x plus 11. Because as we saw earlier, that 11 squared was 121, so 121 is a perfect square. These would be the two factors, and then I'm going to confirm that I made another mistake. And that I shouldn't have done 2 times 8, I should have done 2 times 4. So my a value in this one was actually 4, it wasn't 8. So I'm going to put 8 here, I'm going to put 8 here. Your answer here should have actually been 44 over 8. So that's the one tricky thing. I put 2 times by 2a. So my a here was 4. I needed to plug in 4 for a, so it's 2 times 4 equals 8. Again, I'm just demonstrating you left and right. Try not to use quadratic formula. Try to factor stuff instead. You would have made fewer mistakes had you factored this and then use zero product properties. So let's get the correct answer. 44 divided by 8, not divided by 16, is 5.5. So plus or minus 5.5. And that's what I would have gotten here using zero product property, okay? This thing in its factored form is this, equal to 0, and 2x minus 11 equals to 0. If we're going to use zero product property to solve, 2x equals 11, and x equals 11 over 2, which is the same thing as 5.5. And the same would be true for this factor, except it would be the opposite. It would be negative 5.5. So factor if you can, but right now it's asking you to practice the quadratic formula so that you can get used to making mistakes, right? Get used to making mistakes using the quadratic formula, and then you can be on the lookout for those mistakes in the future and get through problems and actually use this thing effectively going forward. All right, pause the video now. Try B, C, D. I'm a little bit tired of making mistakes in front of you, so let's see if I can do them by myself without making mistakes here. Ready, set, go. You got this.
Shockwave central power on the motherboard, yes. Push up, overload, legendary, heavy glow, sunshine, thunder roll, keep this on. Yes, the lantern burn at easy, and broadcast so raw and easy. Thunder roll, sunshine, work it out, out.
Just to get through the week, sometimes it's hard. Right now
book got, because I'm not checking my answers this time around, but I feel like I probably got it right. And I hope it's what you got too. Work through these successfully. Be successful together here. First one here, remember all these ones, I'd always write down your A's, B's, and C's. Got to know your A's, B's, and C's. And here, this was just out of order. This was just not written in standard form. You need to rearrange the terms. Leading term should be the x squared term, but it should be followed by the x term and then the constant after that. So C here is -2, and that goes over here in the equation. Go through and solve. Not too much to say about this one. 2 or -1/2 is what I got for my answer. This one here we can talk about a little bit longer here. There was actually one way to make this an easier quadratic to use the quadratic formula for, and I'll get to that later. But what I got when I went through, first things first, right? List your A's, B's, and C's. What I always do is I kind of rewrite this in the standard form. So I needed to move this -630 to the other side of equal. So I needed to add 630 to both sides. So C here was not -630, it was +630. And that was a problem, right? When we put into the quadratic formula, we did this, right? Our B is a pretty large value. -165 squared is almost 30,000. But 630, so -4AC, 4 times by A is 15 here, and that would be -60. And -60 times 630 is actually larger than, or much smaller. The absolute value of it is much larger than 165 squared. So here we have 27,225, and we're taking away a value that has a larger absolute value. So we end up getting a negative radicand here. This, what's underneath the radical symbol, is called the radicand. And can we have a negative radicand? Is that allowed? No, we can't take the square root of a negative number. There's no real number that when squared is a negative number. No two numbers times themselves, no two real numbers times themselves are a negative square. So there is no real solution to this problem. The thing that I was going to say earlier, and maybe you contemplated this here, is how could you have maybe simplified this a little bit? At this step, you could have actually simplified this one before using the quadratic formula, and then the numbers may have been a little bit easier to work with. Well, how would you get some smaller numbers out of there, right? If smaller numbers are easier to work with, what's one legal move maybe you could have done to both sides of the equation? Okay, on this one here, you actually could have divided both sides by, let's see if you can divide it by 15. I'm not sure if 15 goes into 630. It does. Okay, so 15 does go into 630. So all of these are, the number 15 is a common factor. So, right, 15 is common factor. Put CF for that. Of all three of these numbers here, all three of these coefficients, all three of those terms here. So I could have pulled out 15, and if I divided both sides by 15, when you have, the nice thing is if you have 0 on one side of the equation, you need to divide both sides by something, or you want to divide both sides by something, 0 divided by anything is just going to be 0. So over here, if I divide the left side by 15 and right side by 15, I could have rewritten my equation as this: x squared minus 15 goes into -165, a -11 times -11, and then 630 is 15 goes into that 42 times, as we just saw, equal to 0. So this could have been a way I could have rewritten this equation. That would have been a lot easier to put into the quadratic formula, because I know -11 squared is 121, and I know that 42 times 4 is going to be larger than 121, right? It's going to be right 168. And then, so I would have confirmed that there were no real solutions. And now I'm confident I didn't make any mistakes here. Okay, and I would have gone faster in a problem like that. So that's just one trick to move a little more quickly with the quadratic formula. Last one here, we have D. And this one here is similar to the one in part C, where you just had to rewrite this in ax squared plus bx plus c equals 0 form, and then use the quadratic formula. List my A's, B's, and C's, and I got 5 6 as my answer. Something interesting here happened within the square root also. So the radicand, when you simplified, you should have noticed this. You got 3,600 for -60 squared, and then -4AC was also 3,600, but -3,600. So this part here, what was inside the square root symbol was 0. So what happens here? Did you get the same answer as I did? So when the square root is actually 0, you only have one solution. This plus or minus thing doesn't matter, because we don't really have a quantity over here. We have a quantity of 0. So when you have 0 underneath the square root, you're only going to get one solution, right? One solution. So on a parabola, let's say if this thing were a parabola, this would look like a double root on the graph, okay? So this is a double root. We have 2 roots on this one here, 2 roots on this one here, no real roots on this one here, and a double root here. So when you only see one answer, that's actually kind of a fancy way to calling it, because these are all roots, right? This is all the values of x when the other side's 0. A root, right, is the value of x1 that makes the expression equal to 0. There's only one root in this quadratic. So when there's only one root in that quadratic, a lot of people call them double roots. And it's just something to be aware of. Because other polynomials will have a certain number of roots, right? That's something that you'll study in the future, that depending upon the type of equation that you have, you'll get a certain number of roots, and some will be double roots, so you can count them twice. All right, last question here. Another application of parabolas. So we know that downward-facing parabolas are when we throw something in the air, right? It makes a U shape, right? We toss something in the air, and it's going to be launched off, and it's going to hit a peak at some point, right? The vertex. And then when it starts coming down, it's going to come down in a perfect vacuum, right? Like in a perfect scientific experiments, right? If you take in all other variables, if you threw it up, hits a vertex, it comes back down in exact symmetry as the launch of the water balloon, for instance, or the rocket or the plane or something. So another application of this is some design is going to be designing an arch. An arches are parabolic, as we see here. Anybody been to the Golden Gate Bridge? Well, the suspension system's quadratic, but it's parabolic, but it's upward facing, not downward facing. Okay, so let's look at the St. Louis Arch problem. Arches like the St. Louis Gate Archway. I'm going to read the problem, do a little bit of it, but you should do it on your own. Ready, set, go. Let's get the x-intercept. So that's the value of x when y equals 0. And I have this. Does that look factorable? Well, is negative 0.00635 a perfect square or 630 a perfect square? They don't look like them, okay? Don't look like perfect squares. This does not look like a difference of squares, so I'm not going to factor this. We're going to use quadratic formula. So this is tricky. Hey, actually, one way I could make this a little bit easier if I didn't like all my decimals is I could multiply this a bit. This is what I'm going to try to do to make this just a tiny bit easier, for me at least. I'm going to multiply both sides. Okay, I'm going to multiply it, so instead of getting 0.00635, I might change this to 6.35. So if I multiply both sides, and I want to move it 1, 2, 3 places over, then I can multiply both sides by 1,000. And that would make it at least, so I wouldn't have that crazy small decimal right here. So 0 times by 6.35, that's another thing. When you multiply something to 0, it just becomes 0. We have 0 on one side. And this would be 630,000 for the constant in this problem, and we're minusing 6.35x squared. All right, let's do the quadratic formula. My a in this situation, negative 6.35. My b, there is no b. We don't see b, so it must be 0. And our c is going to be positive 630,000 because I rewrote my equation. I'd rather deal with a bigger number here than kind of like a decimal that I don't really understand, and there want too many zeros over here. Okay, so quadratic formula, x equals negative b, so that's just negative 0. So I'm going to do plus or minus the square root. B squared is 0, so I'm just going to do minus 4ac. So minus 4, negative 6.35 times by c, 630,000, all over 2a. So for my x-intercepts, I got about 315, 0, and negative 315, 0. So check your answers here. Let's look up at the context of the problem. What does this mean in the context of the problem? Well, x-intercepts looks like that's probably going to be the roots of the graph or the x-intercepts, but it's also where the arch is rooted. It looks like we have our y representing distances in feet, but y is probably the vertical distance in feet. So when y is on the ground, right, no vertical distance from the ground, that's going to be my x-intercepts at 315 and negative 315. And that's written in what units? Feet, okay? So negative 315 feet from the left of the line of symmetry of the parabola is going to be where one of the roots is, and 315 to the right of the line of symmetry, looking at the archway, of course, perpendicular to the archway, is going to be the other intercept. How wide is the arch at this base? At the base? Well, if we're 315 feet this way, and then another 315 feet this way, I'm going to get rid of my negative there because it's negative 315, but 315 feet, another 315 feet, it would be 630 feet wide. That's pretty wide. That's over 2 football fields wide. It's a pretty big arch there in St. Louis. How tall is the arch? How did you find your solution? Well, how do we get the height here? Well, we got to go back to our water balloons assignment. All we really know are the x-intercepts. Do we know the y-intercept? Ooh, we actually do know the y-intercept. So the y-intercept here looks like it's also going to be the vertex. Halfway between the roots is going to be 0. So if we get 315, add negative 315 to it, we get 0, divide by 2. That's the way we can figure out our line of symmetry. So that's going to be at x equals 0 is the line of symmetry. So the vertex would be when we plug in 0 for x, and then it's 630 for y. So it's also going to be 630 feet tall. That's pretty neat that the archway here is both as wide as it is tall. So kind of they thought aesthetically and also mathematically that it was interesting. It was beautiful that it looked that way. Draw a quick sketch of the arch on graph paper, labeling the axes with all the values you know. I'm not going to do that on graph paper. You don't really have to do that too. So let's just do a sketch of this. So you should do a sketch down here. X is going to be the distance from middle of arch in feet, and y is going to be height from ground in feet. Draw our sketch. It should be symmetrical about the y-axis. So I didn't draw that super neat looking. Okay, and the values I know, this is going to be 630, this is going to be negative 315, and this is going to be 315. Boom. Archway sketch done on graph paper, and that's what we know, and assignment done. This one shouldn't have taken too much time. My explanation probably took longer than it took you to take it, but remember, right, quadratic formula can be messy. You want to avoid using this when you can. Use zero product property, use completing the square, and then you can check your answer using the quadratic formula. But hey, Mr. Fortin's making mistakes through this, and maybe you did too, maybe you didn't. But I think it's messier, so try to use the cleaner stuff when you can. Last thing on here on this assignment is the math notes, methods and meanings. It's for solving a quadratic equation. Now, I definitely want you to read this math notes. I want you to read all of them, but this one's especially important because this whole chapter is talking about solving quadratic equations. And not to overwhelm or confuse you guys, we've been talking about this for a while, even in chapter 8. So here, this should look familiar because I assigned this over our extended spring break. That's what I'm calling it now. And I had those instructional videos. If you didn't do those, go back and find those on Google Classroom. They should be the second thing listed under the distance learning section, right before you see the Zoom meeting, right after you see the Zoom meeting info, this course schedule, the online textbook, that thing right below it, you should see an assignment for solving quadratics and sketching parabolas. So originally I told you there are 6 ways to solve a quadratic. In this math notes box, they go through 3 of those just to make sure you know there are these 3 ways that we can do this. That when we have an equation, right, an equation has an equal sign, okay, right, equals 0 here. You could use the zero product property, right? If it's written in standard form, certainly you can factor it, use zero product property to solve, okay? So next one that you've all learned here is the quadratic formula, okay? Set equal to 0, we can use the quadratic formula to get the same answers. So if you look at this and you think about it, right? Yeah, x has got to equal -7/3 or 2 in both solving methods, because those are the solutions. If we plugged that in for x, we would get 0 on both sides of the equation. Either of those things to plug in, okay? And then the final one here, notice here they changed the quadratic in the last one because we've only learned how to complete the square when our front term, ax squared, when our a is 1. So your book here, right, it just kind of wants you to have your leading coefficient also be a perfect square. And we can't use completing the square with this 3x squared thing here. We haven't learned the methods on how to do that yet. But the only thing we reviewed is completing the square where our a equals 1 or a perfect square in front. So x squared is a perfect square. You can put that in the bottom left corner of a generic rectangle, and then x times x would be part of your 2 dimensions, your base times height calculation to get a complete square. If you have 5 x's, so remember you have to divide the middle term by 2, because that's how you're going to break out where you're going to lay out your x's. You got 2.5x here, 2.5x here, right? I would set up a generic rectangle every time you do this, and it's very quickly. 5x here, I'm going to put 2.5 of them here and 2.5 of them there, and that's how I'm splitting up my 5x's. So the square that I'm trying to create is x plus 2.5 squared, and this would have to be 6.25 on there to get this to be a perfect square. We don't have 6.25, we have 4, so that means we have to add 2.25 to both sides, as they do in the example, okay? So they can even get the vertex form of a quadratic function using completing the square, or you can just solve for it, right? This equals 0, and you can use the square root method to solve for both sides. Okay, those are the 3 ways, and that's the stuff you need to know, right? Taking the square root method after completing the square is kind of one method entirely together. You know, I know I put 6 here earlier, and that's just because I wanted kind of to lump things together in the chapter 8 unit and chapter 9 unit. So not all of these here, not all 6 of these are actually ways of solving, right? So solving quadratics. These were all ways to sketch a parabola. So factoring zero product property, that's definitely one way to solve a quadratic, get answers for x when y equals 0, for instance. But graphing calculator, that's not really a way to solve a quadratic. It's a way to find the answers of a quadratic. Basically, it's just a way to look up the answers of a quadratic. You can plug the parabola into your graphing calculator, and for whatever y value you're looking for, find whatever x values, get that y value, right? So it's kind of just a way of using your resources to determine an answer. It's not solving quadratic. And it's also a way to sketch a parabola, right? If you have a graphing calculator, you can sketch the parabola immediately because the graphing calculator shows what it is. Vertex form to standard form, that's not a way to solve a quadratic, right? That's just a way to, if you have something in vertex form, I just wanted to show you, if you have something in vertex form, that's enough to graph it, because all you got to do is pull the vertex out and then change it to standard form, right? Distribute x minus 2 times x minus 2, and then do your multiplication, and then combine like terms, because then you can get the y-intercept if you change it to standard form, okay? Not a method to solve equations. So factoring is really the only one in the first 3 that I made the videos on. Haven't made videos on steps 4, 5, and 6, but steps 4 and 5 kind of go together, right? You complete this square, for instance, right? We would have to get this to be 25. Half of -10 is -5. -5 squared is 25. So I'd have to add 11 to both sides. To get my vertex, if I add 11 to both sides, I would have y plus 11 equals x minus 5 squared. So I would know that this vertex was at 5, 11, right? I'd have to add 11 back to both sides. I'm just doing this in my head. If I completed the square here, y equals the quantity x minus 5 squared plus 11. So 5, 11 would be the vertex. So it's just a way of getting a vertex to help you graph it out. You'd have the y-intercept here, but you also solve equations, right? If we knew what y was, for instance, if we had a y value here, we could complete the square on this side and use the square root method to solve a quadratic equation by taking the square root. If y is 9 here, then we can add 16 to both sides and then take the square root, and it would be plus or minus 5 on this side equals x plus 1. So anyways, these kind of go together. And then quadratic formula is the new one. I'll try to make a video on these later, just so that we have videos in all 6 of our methods. But important that you read these. We've made it, guys. We have all of our methods to solving quadratic equations. So you might be wondering what's coming up next. We haven't been on chapter 9 very long. Well, we're going to get to inequalities very soon, because inequalities, you've seen them in the past, and they've been rather simple. They're going to get more complicated now, because now we know how to do quadratics. We might have quadratic inequalities with, normally we get multiple answers for a quadratic equation, right? Because we have that plus or minus thing. We might have multiple solution regions for a quadratic inequality problems, and that's still to come. All right, thanks again, guys. Have a great day. Bye.
This is the rhythm of the night. The night. Oh, yeah. The rhythm of the night. This is the rhythm.